Good morning friends. Today I am going to explain the most important topic of mechanics, that is angular momentum. Okay, before going to talk about this angular momentum, first of all, what is momentum and what is linear momentum? In your previous classes you have studied about that momentum is nothing but a product of mass and velocity, and linear momentum is nothing but a summation of I is equal to 1 to n. It's a product of MIVI. Okay, so these topics we covered in the last videos, that is what is linear momentum and law of conservation of linear momentum. Now what is angular momentum? Angular momentum is nothing but it's a product of position vector and the linear momentum. So for that purpose, consider a particle of mass m having a position vector r with respect to the origin O of inertial frame of reference. What is inertial frame? That is x, y, z. Here this is the one inertial frame of reference, that is nothing but a frame of reference in which the Newton's laws are holds good. Okay, now in this frame of reference, let us consider a particle p or any particle whose mass is m, and which is at a distance of r, or that is the position of vector of this particle from O is r. Okay, so this is rotating. So when you rotating, when it is rotating, it makes an angle theta. Okay, so here let p is equal to mv be the linear momentum of the particle in the inertial frame of reference, or in this inertial frame. Okay, now we know this. Next, angular momentum. Angular momentum I of that particular particle about O is defined as the vector product of R and P. Here this is angular momentum is nothing but a vector product of R and P. Okay, that the P is linear momentum. Here the direction of I is perpendicular to the plane containing R and P. If we consider a system of n particles, okay, so this is the general definition for the angular momentum. Now here this is also angular momentum definition, but when when a system is consistent n number of particles, so that time the angular momentum L of the system about origin O is can be written as, here angular momentum is represented by L is equal to I is equal to 1 to n I, and this can be written as I value is what, R cross P. So this can be written as I is equal to 1 to n Ri Pi. So here the angular momentum is nothing but it's a product of position vector and the linear momentum Pi. Pi is nothing but a linear momentum, that is equal to the summation of MIVI. Okay, I is equal to 1 to n MIVI. Thank you. For more videos, subscribe my channel Physics.